Hello, everyone, and welcome to today's webinar. Today, we're going to be talking about jumping the 3 big hurdles to predictive modeling in retail. So we're going to go through all of the steps that are involved when preparing data, building models, and making models useful to the end user. I'm really excited to be here today with Jordan Elkind, who is Custora's head of product. Please chat questions you have along the way, and Jordan will answer those definitely by the end of the webinar. And if we don't, for any reason, get to your questions, then we will definitely follow up via email. As always, we'll also be sharing the deck and the recording after this webinar. And I'm going to now pass it over to Jordan.
Thanks so much, Maddie, and good afternoon, everyone. I'm very excited to be here with you to get a chance to talk about one of my absolute favorite topics in the world. It probably gives you a sense of how much I've got going on in my personal life. But first, just a little bit of background information on who we are at Custora. Custora is the leading predictive customer intelligence platform for retail marketers. We work with an incredible roster of retail brands, some of whom you can see on the page here. Each of these brands is really working hard to make the most out of their customer data, to use that customer data to extract insights that will enable them to build longer lasting, more relevant relationships with their customers. And so we're very excited to be a small part of their success. And here's what made me excited to get a chance to talk to you guys today. So I've been at Custora for almost 6 years. And in that time, we have built a dizzying library of predictive models specific to the retail space. I'm just calling out a couple of the greatest hits here. For those who are current Custora customers, these may be predictive models that you use as part of your day-to-day business. In every case, these are models that are inspired by real-life retail use cases and challenges, in some cases co-innovated in partnership with leading retailers in the space, some folks who are on the call today. Over the course of building dozens of models, we have learned a thing or two about predictive modeling and some of the common snags that tend to lie in wait on the road to getting from an idea to a fully executed model. And so the goal of the webinar today is to share back some of what we've learned along this journey with you guys, to help inspire you wherever you are on the maturity curve, whether you have not yet begun digging into your data or whether you've got a team of data scientists in-house. We hope that there's some experience and perspective that we're able to share with you. And we're eager to hear your feedback as well. So as Maddie mentioned, please feel free to chat us questions, commentary, disagreement, whatever the case may be throughout the course of the webinar. So first, we are going to start with a little poll. Just to get a sense of context where folks are who are part of the webinar, I'm curious to know where your team is in the predictive modeling journey. So perhaps you have not yet taken any steps towards exploring the data. Maybe you've begun to explore in kind of an ad hoc fashion. Maybe you're actually running models, but you haven't really brought them into a production ready environment, or you actually have fully production ready models that are being deployed at scale. Let's take just another moment to collect some of the response data.
All right.
Okay, the results are in. Really interesting. It looks like the smallest group here is folks who would characterize themselves as being in the most mature state, having fully production ready models that are being continuously updated and deployed at scale. Other than that, we're seeing a pretty even split across the 3 first stages. So folks who are just beginning to take the first steps through those who have some experience under their belt and are looking to get from kind of one-off ad hoc model work to a more always on modeling approach. That's great context. So let's move on to the next poll, which is an immediate follow-on. Curious where your team spends the most time. If you are in one of those stages of doing predictive modeling or exploring the data, what is the most time-consuming activity for your data team? Getting some good responses here. We'll take just another few seconds. Really interesting. So just to share back what we're seeing, this is very unexpected, I have to admit. It looks like the vast majority of folks are spending the majority of their time on kind of the data preparation step. So cleansing data and stitching it together. And then some small minority of folks spending time doing actual modeling experimentation, what we would think of as R&D. Similarly, a small percentage making models useful to the end user. Nobody mentioned model maintenance, although perhaps you are already doing it without even being aware of it. This is great context. And in a way, this actually cuts against the point that I was about to make. It sounds like this is a more experienced group than I was expecting. Oftentimes when we speak with organizations that are early on in the maturity curve, so they have just started hiring data scientists or building their own in-house data science capabilities, there's this incredible rosy picture of what the end game of data science will look like in their organization. Basically, they'll spend the vast majority of time on exciting R&D projects, experimenting with different types of models, neural networks, logistic regressions, machine learning of all stripes, and then some percentage of time on kind of improving and maintaining the performance of those models. On the right-hand side, you can see an admittedly utterly unscientific breakdown of how we see teams spending their time in reality. In reality, we find data science teams wearing many, many hats and finding their time spread thin across a number of activities involved in basically going from ideation, like what is the business problem that we want to solve, through having a fully functioning model that's producing output at scale. Now, some of the things that go into then, we'll dive into each of these in a bit more detail, are things like the stitching of data sources together. So, hey, our customer data is spread across 16 different systems. How do we get it into one place? Cleansing that data, so standardizing data variables, for example, doing things like user deduplication and consolidation, running the models themselves, maintaining them, making them useful to end users. These are all things that take time. And often we find organizations that don't have experience in building models tend to be surprised by these. They come as a bit of a shock after they've hired their first few data scientists and realize, holy crap, there's actually a rather complicated supply chain of activities that have to take place to go from the raw data to action built on those insights. Now, the three big hurdles, this is 30,000 foot perspective, are number one, preparing the data. So what are the steps that we have to take to slice and dice our vegetables before we even start sauteing them? Then there's building the models, which you can think of as basically how do we spice and prepare that stir fry? What's the recipe that we follow to make it as tasty as possible? And then making the outputs useful, which you can think of as almost the presentation or the plating, right? How do we show off our work to maximum effect and make it impactful throughout the organization? So there are these three absolutely foundational hurdles that we're going to dive into and unpack. Now, because I love things that come in three, I actually, for each of these three things, came up with three sub-steps. Now, if a trilogy of trilogies sounds confusing, I would invite you to think about Star Wars as an analogy, right? How they're the three big Star Wars plot arcs under which each of them has three movies. Please don't pretend that you don't know what I'm talking about. Just by virtue of being on this webinar, I know that you're kind of a geek. So within each of these three big areas, preparing the data for modeling, building the models, and making the outputs useful, we're going to dive into the three kind of sub-challenges and how we would recommend approaching them. And all the while, please feel free to chat, questions, feedback, comment, and we'll take questions at the end. Okay, so we're in the kitchen. We've got all of our raw ingredients and we need to prepare them to make a dish. How do we actually prepare the data for modeling? Now, step 1A is one that in my mind is often overlooked by companies. And in our experience, we tend to find that retailers, especially ones that have invested in significant data science resources, a team in-house, will typically race to build 6 different models and become a little bit like a hammer in search of a nail. So they've got a model and they're looking for a business problem to solve. In contrast, the organizations that we tend to see being most effective actually start with a pretty clear-eyed view of what is the business challenge that they are trying to surmount. And that guides the prioritization of what models to build. And so just to give you an example of what this might look like in practice, let's say that we're BigStore Unlimited. We're a vertically integrated specialty apparel retailer. And we've been noticing a shift in our business over time. Now, it used to be that we lived and died by the success of our product launches, and product was everything. And in order to track the success of product sales and sell-through and new product development, we had a whole suite of software and predictive analytics to tell us what products we're going to sell. Then came the proliferation of digital channels. And over the past 5 or 10 years, our success at driving demand for the business has been all about our ability to own the tactics in given channels. How effectively are we deploying our SEM campaign, for example, or using audiences on Facebook and Google? And accordingly, we've got some analytics software that's helping us understand the performance of our different channels. But we've noticed a shift in our business recently. We see that the customer, more than ever, is in a real position of power. It's the customer who has endless choice of what to buy, instant price transparency, fueled largely by Amazon. And increasingly, we're having to work harder to get to where she is and talk to her about things that are relevant. The only challenge is that unlike the age of the product and the age of the channel, when we had like a true north, what metrics we were going to measure to quantify our success, we don't really have a way of measuring the goodness of our relationships with our customers. How effectively, basically, are we acquiring, retaining, and nurturing customers within our customer base? Now, this shift towards customers being in the driver's seat and really powering the future of our business, if we're out there talking to our peers in the industry or even just looking at financial disclosures, we notice there's kind of a trend here. More and more businesses are becoming customer obsessed or trying to put customer centric strategies in place, largely built around figuring out who their highest value customers are. And so a really natural way of describing the business problem that we're facing as BigStore worldwide is, hey, we want to be able to identify who our highest value customers are. And we need some metric like customer lifetime value to serve as the true north for measuring the efficacy of all of our tactics, much like we had, let's say, Omniture for measuring the effectiveness of our channels. And to that end, we're going to try to build a customer lifetime value model. Now, just a little bit of background for those on the call who may not be as familiar with customer lifetime value. It's a metric widely discussed in retail, although somewhat less used in practice, as we've found, that basically quantifies each individual customer's value to the brand. And so you can see here a snapshot of 3 different customers. The shopping bags represent their transactions over a given period. Now, of course, the goal of a predictive customer lifetime value model is to forecast how much they are likely to be worth to the brand in the future, based on everything we know about them, what they've done in the past, what similar customers have done, and so forth. Now, some of the challenges of predicting customer lifetime value in the retail context are, unlike a subscription business, let's say a Netflix or an Amazon Prime, our customers unfortunately don't call us up on the phone to tell us when they're resting in between purchases versus when they've left us for good. And so we have to infer from basically an ad hoc transactional and engagement stream who's likely to engage in the future and what they're likely to do. And so that makes it a really gnarly challenge from a modeling standpoint. But it's also a really worthwhile challenge for a retailer like BigStore to address. So we mentioned that, of course, they're looking for some metric that they can use to assess the effectiveness of their customer strategies across acquisition, cultivation, and retention. They've also noticed, and this is probably true for every retailer on the phone today, that a small percentage of their customers contributes a vastly disproportionate percentage of revenue and future value to their business. And so if they're able to crack the nut on who their high value customers are and how to grow lifetime value, that could yield really, really outsized gains for them. And so all of this is a really, really long way of saying that starting with a clear business challenge that you're trying to address, like using customer lifetime value to grow your business actually makes all the difference in the world. And it's a step that's often overlooked. Okay, so we figured out what the business challenge is that we're trying to address. We're trying to segment our customers by lifetime value and use lifetime value to measure the effectiveness of our marketing actions. The next step in kind of our kitchen prep checklist here is unifying and cleansing the data. Now, we could talk about this all day, and actually maybe we will have a follow-up webinar on this to go a bit more in depth. But the basic challenge here, as those on the phone who have taken some steps in this direction might be aware of, is that one of the biggest unfortunate surprises often for data science teams is that for folks who have advanced training in research techniques, statistical modeling, they tend to spend an unexpectedly large percentage of their time on what's called data wrangling in the business. Basically, lassoing together different data sets from different systems and applications, stitching them together, cleansing the data, can be a big pain in the butt. That's the official data science term. It becomes clear why this is so challenging if you look at just a representative sample of what data we might want to collect in order to fuel our customer lifetime value model. For example, without thinking about it for more than 30 seconds, we could probably come up with some list of potential data sources that look something like this. Perhaps we want to gather transactional data, which might be split across our e-commerce system and our point of sale system. We want to bring in email engagement data, which lives within our email service provider. We want to bring in product catalog data to understand the different types of products that users are engaging with. Perhaps we're working with a third-party vendor like an Experian or an Axiom or a Datalogix to bring in third-party data appends, along with first-party CRM data like geolocation. All of the things here are part of the valid universe of potential data points that we might want to bring in, and they tend to live across a dizzying array of different systems and applications that don't always talk to each other. And so the first challenge for any data science team is to figure out how to essentially centralize and map the data. Now, the way that we think about this, and this is just sharing a little bit of Custora's schematic as a thought starter for teams that haven't yet begun going down this road, is to think about a set of common identifiers that can be leveraged across data sources from different places in order to stitch together a comprehensive view of customer behavior. So an example might be perhaps we have one or more different user IDs that enable us to tie together data that's living within our CRM, our marketing database. Think of this as like select star from the users table in your marketing database. We can tie that to orders data from our e-commerce and point of sale system. That orders data might tie to a merchandise feed or catalog using things like SKU ID. Essentially, the core task here is to map out what the relationship is between these different data sources and what set of common or shared keys we're going to use to link across them. Now, data cleansing, and once we've figured out how to bring the data together, data cleansing is the process of essentially ensuring the accuracy and integrity of different data sources. And I think there's often the perception, which I would respectfully counter, right? The data cleansing is like a binary all or nothing thing, right? The data is utterly valueless unless it's 100% perfect. Sometimes you hear this described as garbage in, garbage out. In contrast, what we tend to see is more of a range or spectrum of data cleansing outcomes, let's say, where what you want to implement depends on the level of confidence that you have in your data, and I'll say the robustness of your data capture practices. I've called out three of the major categories of data cleansing initiatives that we see teams undertaking in order to make the data useful and reliable for modeling on top of. Just starting with data standardization, which I think in some ways is the easiest to understand. Imagine that you don't have address validation on shipping address as part of the checkout flow on your website, for example. Well, then it's entirely possible that the same user might show up multiple times in your database with natural variations on their street address. just driven by human error, driven by natural variations in spelling and syntax. For example, California might show up as California, might show up as CA, might show up as California. The data standardization is essentially the effort involved in coercing variable inputs towards a single standard, whether it's, as we show here, street versus ST, standardizing things like city names and country names and so forth, product names, so that we can group together like entries within a table. And we know, for example, if Maddie's name shows up alongside 3 different street addresses that vary slightly, that those actually are all the same shipping address. Now, in addition to standardizing the data, there's a really important step that we've spent a lot of time focusing on the Custora side. Those who have begun their own modeling efforts might have their own war stories to share around data validation. This we think of as slightly different, where data validation is really, does the data make sense in the context of what we know about our business? So an example of something that we might want to flag in the data validation process is, for example, a merchandise return that takes place before the transaction date associated with that piece of merchandise. And we know that there's no way that merchandise can be returned before it's actually ordered. So that's most likely an issue with the order system, human error coming into play. Negative revenue associated with a transaction would be another example of a type of variation or anomaly that we would want to flag as part of data validation. But so if standardization is basically making sure that like things are treated alike, validation is checking for whether things make sense, whether the inputs that we have are consistent with standard accounting practices and business rules. And then the third step, or 1/3 pillar of data cleansing, is deduplication and consolidation. So part of the reason that we go to great pains to standardize input, for example, street address, is that enables us to defragment duplicated user records. So going back to this example, let's say Maddie has made 3 purchases as a guest, using the same shipping address each time, but with slight variation. So maybe, once she's on 85th Street, once she's on 85th ST, once she's on 85th Street. Once we standardize those all to the same address, that enables us to collapse all of those separate records into a single customer. And so when we see transactions associated with each of those users, we can tie them back to the same entity. These are just 3 of the types of investments that tend to yield really strong returns when it comes to predictive modeling, because they enable us to basically wring the most juice out of our existing underlying data. Okay, so now we've gone through the admittedly boring step of slicing and dicing all of our vegetables. We're getting ready to throw them into the frying pan. Oh, just kidding. We have one more step. Very often when we work with data science teams, one of the challenges that they tend to face going from the raw data to things that can actually be used for modeling is what we think of as transformation and restructuring of the data. And this is essentially a way of saying, hey, how do we take all of the raw building blocks that we have and enhance them so that they're more useful as inputs for a predictive model? I've provided a couple of examples here of commonly undertaken transformations. So for example, let's say that we're a wine retailer and we're collecting date of birth because we are obligated through regulatory restrictions to capture a date of birth that's accurate for every user who signs up for the site. Now, we could use that as a raw input in our lifetime value model. There are lots and lots of potential individual variables there. We'd be treating somebody born December 18th, 1985 differently from somebody born December 19th, 1985. So you could say, okay, maybe we should use somebody's year of birth as an explanatory variable. But even that is not necessarily ideal for producing a great modeling output. For example, it might be reasonable to believe that individual year doesn't have too much explanatory power over somebody's lifetime value, but broadly speaking, certain age ranges account for differences in buying behavior. So think of this as millennials perhaps shop differently than Gen X, shop differently from baby boomers. And so we might want to take that raw variable of date and transform it into an age range, like 21 to 34 and 35 to 45. Similarly, those who have a background in modeling or statistics know that there are common transformations undertaken on things like count data or continuous variables in order to make them more interpretable. So an example here is, let's say that we want to use the number of times that somebody has logged into our mobile app as an explanatory variable, right? Totally reasonable to believe that how often somebody logs into the app is predictive of how valuable they're likely to be in the future. The difference between somebody who logs into the app 1 time and 10 times is probably greater in terms of explaining differences in behavior than somebody logging in 10 times versus 20 times, or 20 times versus 30 times. And so a common transformation that we'll see there is a logarithmic transformation that basically condenses down from an exponential scale to a linear scale changes in behavior. So that way, somebody going from 1 to 10 logins would have the same impact as somebody going from 10 to 100 logins. That's the type of transformation that tends to do a good job of capturing changes in engagement behavior, other types of continuous behavior. Another common way of transforming or restructuring the data that we see is going from some sort of transactional or behavioral attribute to something that exists on the user level and can be used as an independent attribute in, let's say, regression modeling. So an example of a transactional attribute would be the channel associated with a given transaction. The way that we might see a team flattening that or converting that to a user level attribute would be saying, hey, Jordan made 6 purchases last year. What was his first purchase transaction channel or his most common purchase transaction channel? And that enables us to cleanly define user level attributes that can be used for predictive modeling. And so just to quickly recap, on the data prep side, we've got defining our business challenge, the all too overlooked first step of figuring out what the heck we want to build a predictive model to solve. Number 2, stitching the data together and kind of the varying spectrum of data cleansing and consolidation that we want to do. And then 3rd, taking our raw building blocks once the data has been stitched together and transforming them in a way that's well suited to predictive modeling. Okay, challenge number 2 is how do we actually build the models? Now that we've got all of our vegetables sliced up, what recipe should we follow to saute a delicious stir fry? Okay, step 2A, and you'll notice I'm starting with like the annoying pedantic stuff rather than the fun, gratifying stuff, but these are the steps that tend to get overlooked and then very significantly regretted as a result after the fact. It's absolutely essential before we embark on a scattershot shotgun approach of R&D to identify what benchmarking and validation framework we're going to use. For example, how do we know when we've stumbled on a good model? How do we quantify the goodness of the model? How do we know when it's time to find a better model? And this might sound super obvious, right? For those who have taken statistical modeling classes, that we basically think of the world in terms of goodness of fit, both in sample. So how well does a model explain the variability that we see in the behavior of interest within the time frame that we're studying, and then out of sample, which is basically how do we prevent from overfitting for a given sample period and ensure that our observations or predictions are statistically valid outside of just the training time frame. It turns out this is actually like a topic for another deep dive webinar. Good to know I'm giving myself a lot of homework here. The way that you as a team should think about validating the fit of model actually depends on how the model itself is going to be built and what the purpose of it is. Thinking about our example here of customer lifetime value, you could actually imagine a couple of different ways of building a customer lifetime value model. For example, perhaps you want to actually score customer lifetime value down to the individual user level. If you as an organization anticipate taking action on user level CLV. For example, using lifetime value scores to optimize your bidding strategy within the SEM realm. And in that case, you might want to use a validation framework that quantifies the goodness of fit or accuracy on the individual user level. One example, a couple examples of individual level validations would be things like root mean square error, root mean square log error. These are basically a measure of how far on average are we when we look at an individual user level. We say for Jordan, I'm going to be worth $100. I'm actually worth $110 during the out of time validation period. Now, that's a validation framework that's very well suited when the use cases that we're looking to pursue rely on accurate individual level forecasts. More often than not, though, it's the case that the use cases that we're interested in actually take place more around categorical sorting. So an example of categorical actions taken on lifetime value would be things like we want to undertake clienteling outreach for our high predicted lifetime value customers, or we want to use our high lifetime value customer segment in order to fuel lookalike predictive modeling. These are things that don't rely on individual level accuracy of the CLV model. They rely on accuracy of categorical sorting. So how effectively are we able to tease out which users are in fact in the top 1% or 5% or 10%? And so if we're building a model where the primary goal is to take, I'll say, categorical or segment level action, we might consider a different type of validation framework, something like a confusion matrix, which enables us to classify basically our percentage of false positives and false negatives against true positives and true negatives. We might use something like the chi-squared goodness of fit test to answer questions like, hey, did we do a statistically significantly better than random job of forecasting who's likely to be in our top 5%, 10% versus bottom 50%. In any case, there's much deeper that we could go here, but the primary takeaway is there's not a one-size-fits-all validation framework. You should choose a way of evaluating model fit that's aligned with the anticipated use cases, how your company is actually planning to take action on the output of the model. Okay, so now we get into the meat and potatoes of R&D, and I'm actually not going to spend that long on it, although it's a lot of fun. This is what we think of as the classic kind of data science, good old-fashioned data science work, which is experimentation with different models. So if we're BigStore worldwide, thinking about building a CLV model, the good news is there is absolutely no scarcity of ways that we could skin the cat. There are lots and lots of potential models that we could build. For example, maybe we want to go with a linear regression, straight line extrapolation. Maybe rather than building a single regression model for the entire customer base, we want to cluster the customer base into homogeneous segments and run separate regression models for each of those. Perhaps we want to build up a probabilistic model like the Pareto negative binomial distribution. Perhaps we want to use RFM. Perhaps we want to use some kind of hidden Markov chain or map model. There is an extensive literature on literally the hundreds of machine learning techniques and business rules, in fact, that can be used to forecast customer lifetime value. More important than me enumerating the dozens of potential approaches that you could take to customer lifetime value, what I'd like to leave you with is a really simple framework for evaluating models against each other. This is what we use internally at Custora, and we think of it as a helpful decisioning heuristic when we're evaluating whether we want to invest in building out some new proprietary enhancement to a model. The major trade-off that we see is between model power and interpretability. What this means on the one hand, model power being how accurate is the model, how robust is it, how powerfully does it explain the future, and interpretability being how easy is it for us to extract meaningful, shareable insights about the actual workings of this model. It's quite often the case, and I apologize, this is kind of a goofy visualization here. It's quite often the case that we see teams that in their zeal to optimize model power will actually sacrifice model interpretability. In many cases, this comes from throwing too many explanatory variables at the model. So what we're showing here is, basically, like, by increasing the number of variables, it's almost always possible to overfit the data in question. But it's quite tempting, right, to continue throwing more explanatory variables at the model, more proprietary enhancements, more complexities and nuances to explain customer behavior. So perhaps rather than 3 regression clusters, we have 20 regression clusters. However, at a certain point, not only do we begin to see significant diminishing marginal returns in the explanatory power, which is why it can be helpful to use some sort of information criterion that basically penalizes additional independent variables that are thrown into any model. But perhaps more importantly, it erodes our ability to explain to key stakeholders within the organization what the heck is going on under the hood, how the model is architected, what story it's telling us, what insight it sheds on how our business operates. And more often than not, we've seen that when we lose our ability to tell an easily interpretable story around models, that really jeopardizes our ability to be thought leaders and mobilize the rest of the organization to take action with us. And so just to hammer this home again, the 2 dimensions that we're going to be looking at, regardless of which machine learning approach we undertake, are how much power does it supply? That's a validation exercise, but also how interpretable is it? How easy is it for me to explain it to my grandma? The final stage of actually building the models, and this is another stage that is unfortunately all too overlooked. In fact, I can't help but have my feelings a little bit hurt. Nobody listed this in the poll as something that's keeping them up at night. This keeps me up at night for sure. And so without fear mongering, something that we see tends to be a big challenge for companies is in the model building stage, coming up with a process for kind of ongoing monitoring and maintenance of those models over time. It is a fact as inevitable as the changing of the seasons, the fact that each of us gets older year after year, that predictive models degrade in performance over time, no matter how beautifully well built they are up front. Think of this almost as like the law of predictive modeling entropy. But a model begins degrading the second that it rolls off the production line. And there are totally natural, very easily understandable reasons for that have nothing to do with your quality of your data science team. But all of them come back to the fact that the past, the universe that we built our predictive model on, becomes increasingly less representative of the future for a variety of reasons. For example, we all operate in a dynamic business context. It is inevitable over time that we will see internal changes in business strategy. These could be things as subtle as changing budget allocation across different marketing channels that lead us to pull in a different mix of customer types, perhaps more discount-seeking customers than we had previously, that changes kind of the overall relationship of customers with our brand. These might be changes in our product assortment. Perhaps we're making a conscious decision to go more upmarket or have more affordable entry-level price points. This could be changes in the types of markets that we operate in. All of these internal strategy changes render our previous data increasingly less informative of what's likely to happen in the future. And so we need to acknowledge that any predictive model that doesn't take those into account is likely to obsolesce over time. Additionally, although this is more a factor perhaps in other industries besides retail, we see external changes driving a tremendous amount of dynamism in customer base. So this might be, for legacy retailers, the entrance of new competitors, perhaps disruptive direct-to-customer alternatives that really shake up the competitive landscape. These might be changes in the regulatory environment. In fact, things like GDPR, that fundamentally change our ability to market to and serve EU data subjects. These are examples of external changes that render our predictive models based on previous data increasingly less representative of what's likely to happen in the future. And then, oh my gosh, I am so sorry to have to bring up this point. It's my least favorite one, but the data just changes over time. Maybe you've seen this with your own data feeds. This is a headache of every data scientist we work with, due to changes in data structure, changes in many hands touching the data. Perhaps at one point we used to classify a channel as SEM, then we began classifying it as paid search, then CPC. The same product category over time might change its classification. We might go through a merge hierarchy. Perhaps things that used to be tagged as blue are now broken down into 16 different types of blue. It's inevitable that there will be a splintering or restructuring of the data itself over time. And so I'm not calling these out to alarm anybody unduly, except to point out that models, any model that is well built will see kind of a natural degradation in performance over time. And the responsible thing to do at the time that we build the model is to figure out how we're going to continuously benchmark the performance of that model and set guardrails so that we know, hey, when our lifetime value model falls below a certain threshold of accuracy, that's the moment when we want to retrain it on all of the new data that we have. Okay, so we've sliced up our delicious farm fresh ingredients. We've sauteed a delicious stir fry. Now we want to plate it in the most glorious and gorgeous way possible. Challenge number 3 is all about how we make the outputs useful, so that our data science efforts don't just sit on the shelf gathering dust. They actually drive action within our retail organization. Okay, challenge number 3A. This is a biggie. How do we set up the model to go from kind of ad hoc one-off runs to actually being ready to run at scale? Harking back to our original opinion poll, this was actually a snag or hurdle that a number of respondents found themselves at a fork in the road, where it's like, hey, I have a lifetime value model. We're able to run it, let's say, once a year, once every 6 months. Nobody said this explicitly, but I'm reading between the lines. It takes a week for us to actually run the model. How do we get it to become a more regular thing? The challenges that you have already faced or are soon to face are numerous in going from kind of an R&D ad hoc model run to something that you can actually continually refresh model scores over time. So just to state what I apologize is perhaps the obvious to folks who have gone through this before, there are a number of things that tend to break when you try to start running a one-off model more regularly. For one thing, it actually creates a tax, a performance overhead or hit on your system to query the data that regularly. So if you're pulling data from your internal operational database, every time you run that query, that slows down the insertion, deletion, updating of records in your database. Additionally, if you're pulling together or transforming the raw data in any way, those ETL jobs, bringing together, let's say, 16 different data sources into a common data environment, that takes some significant processing power. Of course, if you're stitching the data together and transforming it into a user profile, that requires processing. And then, of course, running a model in a one-off way in like an R, Python, MATLAB, SAS environment is quite different from being able to do it at scale. If these are challenges that you are encountering right now, this is a challenge that unfortunately, I don't have a silver bullet to get into over the next few minutes. My ask would be, let's talk about it. We have a lot of experience with teams that have begun to cross this chasm, and we've got some great best practices on how to approach these. Everything from best practices for creating a replica database to avoid performance hits on your primary operational data store, how you can get greater efficiencies around ETL, as well as the actual modeling using open source frameworks like Apache Spark for parallelized computing. That represents a whole can of worms in and of itself. Turns out it is quite difficult to implement these unwieldy open source frameworks that require a good deal of performance tuning, auto scaling, load balancing, and so forth. We've had to cross all of these bridges ourselves, But and we're happy to share everything that we've learned along the way. My primary takeaway here is that unfortunately there's just doing things more often, scaling up what you did in an R&D context is likely to break and create some major overhead for your team. And so as you think about taking this to the next level, you're likely going to want to invest in, or at least investigate, a new set of tools, one that is likely built on enterprise grade ETL tooling and or open source frameworks in order to get you to where you want to go, which is keeping these scores updated on a regular basis. Okay, so you've crossed that bridge. You've implemented Spark internally. Perhaps you use an enterprise-grade ETL tool like Talend or Informatica in order to stitch the data together, and you're using Spark in order to run the models. The next major challenge is, how do we take the modeling output and make it accessible to marketing teams? For organizations that we've spoken with that have essentially armies of data scientists, this is almost an afterthought, right? It's like, oh, we've got the modeling output stored in our system. Unfortunately, unless that modeling output is readily available to marketing end users, it's likely to be significantly under leveraged for making decisions day to day and running campaigns. And I would go so far as to say that it's almost a prerequisite that marketing teams especially have user-friendly, point-and-click, non-query access to the outputs of data science modeling if we want to see them using it at scale. And so part of the focus that we've really tried to chisel in on over the past few years at Custora is developing a querying environment that's built in the way that marketers actually think about day-to-day challenges and ask questions, because we recognize that the smartest data science models in the world are worth totally nothing unless they can provide answers to marketers in a way that is relevant and intuitive at the moment that they have those questions. And then the final stage, now that we're getting ready to serve our beautiful dish here, is to make the model interpretable. I alluded to this a little bit earlier in the presentation as a common pitfall that we see in internally modeling efforts. A data science team stacked with brilliant PhDs will spend months developing a model that is then too complex to explain to the primary users of that model, or doesn't tie in an intuitive way to how key stakeholders think about the drivers of their business. And so a big focus of our work, not to say that the only way to solve this is through a front-end user interface or web application, is exposing the inner workings of the model. How do we get to a certain lifetime value output for a given segment? What are the components that ladder up to or explain that? What are the variables that are explaining the biggest variance in the lifetime value of our platinum customers versus our low value customers? What we've seen is that having some easy lexicon for explaining what's going into the models and what's driving performance is absolutely essential for teams getting on the same page. And so that was a supremely trilogy heavy overview of the modeling universe. But just to recap, we think of there as being three macro phases in the supply chain between raw data and action in the retail context: preparing the data for modeling, building the models, and then actually making the outputs useful. Within each of those, there are a number of activities that you have already found yourself undertaking or are likely to find yourself undertaking that help you kind of achieve the goals of that stage. Our objective here is to share with you in a very non-salesy way some of what we've learned over the past 7 years of building predictive models for retail. I hope that this has been helpful and relatable as you embark on your own journey. As I mentioned, I'm absolutely delighted to have a follow-up conversation on any specific stage in the journey that folks on the webinar might be experiencing friction right now. But with that, I'm going to wrap up and turn it back to Maddie, who's been keeping track of the questions that we have rolling in.
Yeah, so we have a few questions, and we have a few minutes left. So the first one that came in, Jordan, is who are the stakeholders who generally need to be involved in successful cases? What have you seen based on your experience?
That's a great question. So the the whole case study that I've presented here around customer lifetime value, the implicit stakeholder that I should have made explicit was marketing, right? This is a marketing-led initiative. We've worked with retailers, and in fact, not just retailers, but hospitality companies as well, where there's a different business stakeholder, and that's great too. So perhaps it's a pricing project or a store allocation project. In those cases, the natural business owner might be somebody from operations or somebody from buying and planning. Typically, because the first step is starting with a challenge that is critical to the health and success of the business, we find that the lead or one lead champion should be the business stakeholder from whatever the relevant domain is. So marketing, buying, planning, operations, customer service, whatever the case is. It is almost predestined to fail unless that business leadership is accompanied by strong technical leadership and a strong set of technical stakeholders. These are the folks who are going to be instrumental in identifying, I hate to be crude, but where the bodies are buried. So all of the different data sources and where they live, investing time and energy on the part of technical teams for stitching that data together, doing exploratory R&D, building a business case. And so generally the model that we've seen being most effective is kind of a joint governance model of two different types of stakeholders for these projects. One who's representing business leadership, whatever the originating domain is, and one on the technical side, whether that's data science, BI, IT. That governance team should jointly be responsible for building a business case to executive leadership, appointing ownership across their teams and essentially managing the project. But where we've seen things go wrong is when the project itself is owned exclusively by just the technical stakeholders. There's a model that they want to build that's totally detached from business priorities. More often than not, frankly, it comes from the other direction, like marketing or planning coming forward with the thing that they want to do detached from buy-in from the technical stakeholders. So it's important to get both.
Is there anything that you suggest that, say, marketing leaders might read to kind of better speak the language of the more technical side? Because I imagine it might be hard sometimes for marketers and the analytics or data science team to communicate. Me as a marketer, I know, like, I wouldn't even necessarily know what to ask for when starting out.
Yeah.
With a project like this.
I think there are, as a great caveat or consideration, when we talk to technical leaders who have a great productive relationship with marketing folks, what they tend to be looking for in a counterpart is not somebody who speaks the language of modeling, but somebody who's clearly able to articulate a business need and frame it up as a question for the business. And so I don't know that it's necessarily imperative that marketing leadership immerse themselves in Stack Overflow or like data science and engineering blogs. What I think is most helpful is coming to the table with a clear-sighted understanding of what the headwinds facing the business are, what the ask is, and really more than anything, empathy for some of the challenges that go into doing this at scale. Part of my ulterior motive or hidden agenda here is to engender empathy amongst marketing leadership for how darn difficult it is out there as an IT leader, data science or BI leader. You're probably flooded with an overwhelming number of requests. You're servicing different parts of the organizations. Everything's a hair on fire emergency. And at the same time, you're dealing with this incredibly poorly understood supply chain of activities that have to take place in order to build and roll out and monitor and maintain a model. And so more than any kind of silver bullet source to smarten up on data science, I think the empathy is probably my number one recommendation. Yeah.
All right, we have time for at least one more question. The next is, which CLV model does Custora use? You mentioned a bunch of CLV techniques, and why did Custora choose that model?
Custora, I'll start with it at a really high level. If you were to take the 30,000 foot view and squint, so you're staring out of an airplane and squinting at the world of predictive modeling, there are very broadly two approaches to machine learning, which are called generative and discriminative modeling. Now, discriminative modeling, I think, is what most people think of when they hear the term black box, or even when they think of machine learning, which is basically like, let's throw a whole bunch of variables into a model and try to produce some desired output. We don't need to know anything about the underlying process that's taking place. We're just trying to find relationships between the variables. And so one analogy that I've heard that I really liked, I'm probably going to botch it right now, is it's like learning a language without an underlying understanding of like the grammatical structures, just by mimicking like word patterns. Right? It's totally fine to learn a language in that way, and you can produce great sentences. That's discriminative modeling. Generative modeling, on the other hand, starts with a very different approach, which is, let's take a behavior that we want to model, like customer lifetime value, and actually start with a story about what processes are involved in that behavior. For example, if we're modeling lifetime value, I mean, that's not just a thing that happens on its own, somebody's lifetime value, right? That's a product of how often somebody tends to engage with your brand, how much they tend to spend every time they engage, how long they remain a customer before they fade away. We could actually model those processes semi-independently or in an interrelated way, and then ladder them up to produce an understanding of customer lifetime value. In the linguistics example, this is more like starting with an underlying understanding of the grammar. Like, how do we compose a sentence, rather than trying to just replicate like successful sentences that we've seen in the past. Custora uses a generative approach that is based on what's called the Pareto negative binomial distribution, or Pareto NBD, which starts with this notion that every customer has these three probabilistic processes that they're going through: how often they tend to engage with the brand, how long they tend to stick around, and how much they tend to buy in every transaction. What we're trying to do when we look at the customer base is understand the heterogeneity of customers, so how customers are distributed, what's the proportion of customers who shop weekly versus monthly versus once a year, and then find hidden relationships among different data variables. So if we see that, let's say Maddie came in shopping through Retail Me Not and bought a knit top at $19.99 and shipped to the Richmond, Virginia area, how do we find other customers in the database so that we know, hey, 9 times out of 10, when we've seen similar customers to Maddie, they tend to be once a week shoppers, and they tend to be highly discount sensitive and spend this much on every purchase. There's a lot more complexity that we've added to the model to account for some of the gnarly pitfalls and challenges of retail, like seasonality and clumpy purchase behavior and all of those sorts of fun things that tend to muck up well-intentioned models. But at a really high level, the approach that Custora uses is probabilistic in nature, based on kind of the underlying processes that feed into customer lifetime value.
Great. Well, perfect timing. We're out of time right now. Thank you all so much for joining, and please expect the deck and the recording later this evening.
Thank you so much.
Thank you.